Hey guys, today's video is going to be about linear relations, and it's going to use the guided notes that starts with linear relations. And this is what the top of that paper looks like. So linear relations, we've been talking about relations versus functions. Linear relations are points on a graph that make a straight line. Linear relations can be represented by an equation. For example, the equation of this graph can be written as x plus y equals 8. So this equation matches this graph. Linear equations are often written in standard form. Standard form is ax plus by equals c, where a, b, and c are integers. That means that they are whole numbers. They can be positive or negative, but they're whole numbers. And a has to be greater than or equal to 1. So a actually cannot be negative. And the greatest common factor of a, b, and c is 1. So they couldn't be 2, 4, and 6 because those could all be divided by 2. And that would simplify it further. So let's look at some examples and actually put this into practice. So we want to write this equation in standard form. And remember that standard form is ax plus by equals c. And a has to be greater than or equal to 1. And a, b, and c are all integers. And the GCF of a, b, and c equals 1. Okay, so this is already actually in ax plus by equals c form. Okay, so we've satisfied one of these conditions. But then a has to be greater than or equal to 1, and it is not. It's a negative number. So in order to do that, to fix that, what we can do is divide both sides of the equation by negative 1. And so if we divide by negative 1, divide by negative 1, divide by negative 1, we'll get 5x minus 6y equals positive 12. So now we've satisfied this part. A, b, and c have to be integers. That means no fractions or decimals. So we have 5, 6, and 12. That one's good to go. And the greatest common factor of a, b, and c is 1. So since there are no numbers that go into all three of those, 5, 6, and 12, then that means this is satisfied. And so 5x minus 6y equals 12 is our equation in standard form. Okay, so in number 3, we have ax plus by, but we need to move this to the other side of the equation so that c is over there. So in order to do that, we will add 24 to both sides. And that gives us 9x plus 6y equals 24. So we've now satisfied the basic form. A is greater than or equal to 1. 9 is a positive number, so we satisfied that. A, b, and c must all be integers. There are no fractions or decimals, so that one's good. And the greatest common factor of 9, 6, and 24 is actually not 1. The number 3 goes evenly into all three of those numbers. So we can divide both sides of the equation by 3. And another way to write that that's a little bit easier on the left side is to take each number or each section of the equation and divide it by 3. So 9x over 3 gives us 3x, 6y divided by 3 is 2y, and 24 divided by 3 is 8. And then I always check again for the greatest common factor, 3, 2, and 8, because sometimes if you don't take out the biggest possible option, it can still be reduced after you've done it once. So 2, 3, and 8 do not have any common factors, so we've satisfied this, and 3x plus 2y equals 8 is our answer. So let's look at number 5. Number 5 is a little more difficult. We've got some fractions here. So the first thing I'm going to check is it in this general form? And yes, we have something times x, something times y equals c. And so we've kind of satisfied that. Now, a has to be greater than or equal to 1. This is a positive number, so that is satisfied. But a, b, and c are not all integers. We have 2 fractions here. So what we can do, the numbers 4 and 3 have a least common multiple of 12. And what that means is 12 is the smallest number that 4 and 3 can both go into evenly. So I'm going to show you what happens if we multiply this whole thing, the whole equation, by 12. Okay, so we're going to come over here and do some, some mental math, but instead of doing mental math, it's going to be written out so you can see what I'm doing. But that's going to help us get our next step. Okay, so we need to take each piece. So we have 3/4 x times 12. So we're just going to figure out what 3/4 times 12 is. And when we do that, we write 12 as 12 over 1. And because 12 over 1 is how you write the number 12 as a fraction. And then we just multiply across the top and multiply across the bottom. So 3 times 12 is 36, 4 times 1 is 4, and then 36 divided by 4 is 9. So this first term becomes 9x. Okay, then we need to work with the 1/3. So we need to do 1/3 times 12 over 1, which of course you can do all of this in your calculator if you have access to a calculator, but I want you to understand how it works. So 1 times 12 is 12, 3 times 1 is 3, and 12 divided by 3 is 4. So we're going to get, remember this was a negative, so it's minus 4y. And then we have to multiply 1 by 12 as well, because when you multiply something, when you do something to one side of the equation, you have to do it to the other. So we get equals 12. So now we have all 3 numbers as integers. And then we want to make sure that our GCF is 1, our greatest common factor. So 9, 4, and 12 do not have any common factors. So that means that this is our answer. So if you haven't already done so, I would pause the video here and go back and work on numbers 2, 4, and 6 on the worksheet while that information is fresh in your mind. Then come back to the video here and do the notes for the next section of the worksheet. Okay, so slope-intercept form. We talked about standard form first. Slope-intercept form is just another way to write an equation of a line. And in slope-intercept form, that is going to look like y equals mx plus b. And you guys have probably heard that before. You've probably remember this from Algebra 1. That was most likely that was drilled into your head. It can also be written as f of x equals mx plus b. And f of x is exactly the same as saying y equals. So don't fool yourself into thinking that that's f times x or anything special at all. It just means y equals. So don't overthink this. This is called function notation. Okay, so in these forms, m is our slope and b is the y-intercept. Okay, so, All right, slope is the constant rate of change between the points. Think rise over run. This is something you need to get stuck in your head when you think about slope. Rise over run, rise over run, rise over run. Okay, there are how many types of slope? Well, there are 4 boxes, so I'm just going to take a wild guess and say that there are 4 types of slope. And if you guessed that too, then you are correct. So you may want to pause the video and draw these axes in. This is just so that we can draw what the different slopes look like. So the first type of slope is positive. And a positive slope is increasing from left to right. So a positive slope looks like this. The next type of slope is a negative slope. And a negative slope is decreasing from left to right. So a negative slope might look like this. Then we have a slope of 0. And a 0 slope is a horizontal line. So it might look like this. And then finally, we have an undefined slope. And that is a vertical line. So it could look like this. And the difference in 0 and undefined, remember we have rise over run. And so in a 0 slope, we are rising, we're going up 0. We're not going up at all. And so that's going to be 0 divided by, let's say we run 2 spots. It doesn't really matter. You can run as whatever you want, but let's just use 2. 0 divided by 2 equals 2. However, if we do the same thing for an undefined slope, our rise can be any increment that we want. So let's say that we rise 2. Well, if we rise 2, we run left to right, we run 0. We don't go at all left to right. And whenever you divide by 0 in math, I like to say that this 0 just becomes a black hole and it sucks everything into it and the world ends because you cannot divide by 0. And so that is undefined. So let's practice looking at slope-intercept form and graphing graphing equations just from the slope and the intercept. So remember that slope-intercept form is, that's the wrong pen, I'm sorry. Slope-intercept form is y equals mx plus b. And m is the slope and b is the y-intercept. So what we need to do is define the slope. We need to figure out what m is. So y equals mx plus b. So m is 2/5. And then b, our y-intercept, is 7. So what this means, or the way that we're going to do this, is we are going to start on the y-axis at the number 7. Because the y-intercept means the place where it crosses the y-axis. And we know that that's at 7, so we're going to put a dot there because we know it goes through that point. Now remember that slope is rise over run. Oops, not run. And we have 2/5. So from our point on the graph, if we rise 2, so 1, 2, and run 5, 1, 2, 3, 4, 5, and put a dot there, that's going to be the next spot on our line. And then in order to go the other direction, we're going to think of this as -2 over -5, because if we do that, we can all agree that this would simplify to a positive 2/5. But in order to go the other direction on our line and get more points, we need to go the opposite direction. So when we rise -2, that means we go down 2. And when we run -5, that means we go left 5. 1, 2, 3, 4, 5. So our next point is going to go right here. And then we've got room to make one more point, down 2, left 5. And then finally, we can connect our points. And you have to draw arrows on the end because this goes on forever and ever. Just because our graph is 10 by 10 doesn't mean that it stops there. So that is what number 7 should look like. And let's go ahead and look at another problem. All right, so this equation is in standard form, but we need to get it to slope-intercept form. We want y equals mx plus b. So basically, we need to solve for y. So we're going to subtract x from both sides, and that's going to leave us with 3y equals negative x minus 15. And I put the x in front of the 15 because in slope-intercept form, that's the way that it's supposed to be. Now, we need to get rid of the 3, so we'll have to divide everything by 3. And that's going to give us y equals negative 1/3 x minus 5. So that means that m equals negative 1/3 and b equals negative 5. So remember, slope is rise over run. And we have negative 1/3. Or we'll see that to go the other way, we'll do 1/negative 3. So let's start our points at negative 5 on the y-axis. And then we're going to rise negative 1, that means go down 1, and run positive 3, so that means towards the right. And we're going to put our dot there. So rise negative 1, run negative 3. And once you get a couple of dots going, it's kind of easy to just fill in the pattern. So down 1/3. All right, we've gone as far as we can to the right. Now let's use the other version, and we will go up 1, left 3. Rise 1, run negative 3. Up 1, left 3. And that's as far as we can go to the left. So we're going to draw a line through all of our points, put arrows on both ends to show that it goes forever, and you have graphed another line. Congratulations. So a special scenario is vertical and horizontal lines. So when we have a vertical and horizontal line, we're just going to have, here, let's highlight this so that we can see. So we know that if we have, So an easy way to look at vertical and horizontal lines is that for number 11, this is a vertical line. This vertical line only crosses the x-axis at negative 3. And no matter what we put in for y, x always equals negative 3. So our formula is just going to be x equals negative 3. So there is no y value in a vertical line equation. Now in a horizontal equation, this crosses only the y-axis, and it only crosses the y-axis at the point positive 1. And no matter what x is, y always equals positive 1. So these are the equations for our horizontal and vertical lines, and they don't really adhere to any of our standard forms or slope-intercept forms or anything like that. But just as a reminder, a vertical line, the rise can be any number we want. For example, 2. The run, though, is 0. We don't move it all left to right. And you cannot divide by 0. That's bad. Black hole into the world. So the slope is undefined. And then on horizontal lines, our rise is 0. Our run can be anything we want. So let's just say 2. And 0 divided by 2 is just 0. So in here, our slope is 0. Okay, so the last thing I'm going to talk to you about in this video is parallel versus perpendicular slopes. So remember that parallel lines, they run side by side forever. They'll never ever cross because they run exactly the same. And I remember that because the two L's in the word parallel are parallel to each other. So when we have parallel lines, I want you to think about if you were climbing a mountain. Okay? Well, what if there was another mountain right here beside of it? So we don't care about this line necessarily. But this mountain goes up and up and up. This mountain goes up. And those two lines are never going to cross. So the slope of this mountain, as you climb up, the slope is going to be exactly the same as the slope of this side of the mountain. And so the slopes of parallel lines are equal. Now, perpendicular lines run at 90-degree angles. Okay, so these two lines would be perpendicular. They form a 90-degree angle where they cross. And the slopes of perpendicular lines are opposite reciprocals. So I'm going to show you some examples of what parallel slopes and perpendicular slopes look like. So when you're given two lines, you will find the slope of each line. So you have to solve for m, or get it in y equals mx plus b form and find what m equals. Then you can look at which category they belong in. So parallel slopes are when you have -2 and -2, or 1/2 and 1/2. They are equal. But perpendicular, these are negative reciprocals. And what that means is if I have a slope of 3/4, then I flip that fraction and make it a negative. I put opposite reciprocal. You could say -2. Either one is correct. Because if you make it a negative, it's going to make it the opposite. Because if it was already a negative and you make that negative a negative, that changes to a positive. So either way, it's the opposite sign and you flip the fraction. So if you have the number 2, then the opposite reciprocal of that, so if you're going to flip the fraction, 2 is over an invisible 1. Any whole number is over an invisible 1. So when we flip that, it gives us 1/2. And this started out as a +2, so this has to be a -1/2. So +2 and -1/2 are perpendicular slopes. And then if you had +1/3, or let's say -1/3, and then you needed to flip that and change the sign, 3/1 is 3, and this one was negative, so this one stays positive. Now, examples that are neither one. Oh, one more example of perpendicular. If you have a horizontal and a vertical line, 0 and undefined, these are perpendicular. Those are the only ones that look different than these examples. Okay, so neither would be 1/2 and -1/2. So it's the opposite sign, but it's not a reciprocal, and it is the same number, but not the same sign, so they're not equal. Another example might be 2 and -2, or 3/4 and 4/3. They're reciprocals, but they don't have opposite signs. These are all examples of neither parallel nor perpendicular slopes. So these examples will help you answer numbers 13 through 16. Thanks for listening.